So good. The recording is on. So let me formally welcome you and say good afternoon. We have quite a lot to talk about today. So let me take you to the lecture notes. But while I'm doing that, if there are matters arising, anything for the attention of the class, let me know. Is there anything? Um, if none, then we are good to go. And I want to encourage you uh, to follow the lecture closely and also try to ask questions and even make contributions as we uh, progress. Uh, since Vivian joined late, so I'm going to ask her to tell us. Um, she will welcome the class and then tell us what we discussed in the last class. Vivian.
Good afternoon, sir. I'm so sorry, Ajo. I totally forgot. I have a class now. Um, okay. Class we did probability and something inference. What was I don't want to bite my tongue saying it. It's
Mm.
looking like Bayelsan.
Yeah, not by Asia, not by Asia.
Okay, there we talked about probability being is like language of uncertainty, and then we said we use 0 and 1 for probability. When it's closer to 0, it means that it will most likely not happen, and when it's closer to 1, it's more likely to happen. And then we talked about the Bayesian theorem, which is a way to update probability. Yeah, when you add new information or when you get new information, then you will need to play so many things on the board. So yeah, that's all I can say for now. I'm sorry, I'm just trying to organize myself.
Okay, so keep on organizing. By the time I come back, you must have been fully organized, I suppose. So, but I push that to you because you rush into the class and there is need to also uh, ensure that you stabilize. So I hope you are stabilizing. So, well, the key thing that we talk about was the Bayes classifier, which we were able to use to classify whether an email is a spam or not a spam. That can be applied, so we talk about uh, text classification, you know, uh, though we focus mainly on um, text from email messages. I remember I also asked you to gather some data. Am I correct? I asked you to compile data. If you if you have done anything in that respect, just type yes. If not, type no in the chat menu. Uh, but if I didn't give you any, If I didn't ask you, just you know, uh, on your mic and tell me that no,
Yes,
not
I am not sure you gave us any assignment. The only assignment we have pending is on quantitative methods.
really. So I didn't ask you to gather uh, I mean, text messages on your phone and label them somehow. Maybe you thought I was just mentioning that as part. Yes, heritage. You want to say something?
Yes, I think you said something like that, if I remember correctly. But and then Miss Kafaya also now sent us an email to say that we are giving up until August 26th to
Okay,
send, to send the assignment in, or well, class exercise in,
okay.
and that
So
we should download R and do some little play around with it basically.
okay.
I think
Uh,
I think that's a different assignment. That
Yeah,
uh,
that's not on machine learning. That's on quantitative methods.
yes,
okay,
that's a
Oh,
quantitative. There's
okay,
another one on machine learning. I think Prof was asking if you have heard of if there's one particular maybe organization, if they have sent you a mail before. Some people said yes, some said no. The assignment was based on that.
so
ah,
in any case, if you miss it, you can. I will still give you another chance. The idea is that you should be able to apply these techniques to some of the things that we experience on daily basis. So playing your hands around how you can even collect data, how you can prepare the data for whatever machine learning techniques that uh, you want to use, and then you since our discussion will mostly be on uh, the supervised machine learning techniques. In particular, we are focusing on the classifiers. So you need to know how to prepare your data, how to also deploy the technique, the machine learning algorithm, to be able to make predictions. So always practice, and take note of some of those uh, assignments and exercises. So that's fine. For today, our focus will actually be on uh, the logistic regression. Again, is going to focus on text classification. So, by the way, what do we mean by logistic? So, we will talk about that. So, uh, and then we will also see how we can apply this logistic regression to classify, into uh, two groups mostly. So, uh, so we are going to have two groups. and then the technique will be used uh, to classify any new text document into either of the two groups. So, as a background, logistic regression is even going to play almost the same role as the Bayes classifier that we talked about the last time. Both of them employ the concept of probability, uh, uh, but the only difference is for the Bayes classifier. You remember uh, we use we use the prior probability. We incorporated uh, the information or our belief system into the uh, data that we have. So, and that allows us to refine or revise or review our belief uh, when we now look at the posterior probability. So, um, again, there is another type of regression that is very popular, which is called linear regression. Um, Logistic regression is different from linear regression because in linear regression, so you have linear regression, and then you have also logistic regression. Uh, you recall that we always talk about uh, the data that we can use, and our data will normally have uh, the label and then the features. So you will have the labels and the features. So the label, they are usually, they could be, categorical. They could also be continuous. When they are categorical, then it means they are in groups. They are in they are discrete. Um, they are in classes. So you can have spam, for instance, not spam. So uh, the in this case, you are talking of a label that is categorical. Uh, if you are also talking about sentiment, you could say positive sentiment and then negative sentiment. So label in that instance is categorical. So, and I've always told you the categories could be more than two. So if the categories are just two, then we say they are binary. So, but for continuous, they are measured. So they are measurements. something like income, something like um, uh, maybe duration, maybe speech duration, something like distance, and many like that. All these are measured, or rather, they are measurements. So, if our label, if the label in our data is categorical, then that's when we use logistic re- regression. So, so you require that label is categorical. For linear, you require that the label is continuous. So that's the major difference between linear regression and logistic regression. It doesn't matter, the features does not really make any difference. So you could have the same set of features, in linear regression, in logistic regression. So the features can be a combination. So it could be a combination of categorical plus continuous. So the two of them could, come up in the features. And you know how our model is is um, uh, so our model, whether logistic, whether linear, even including the base classifier that we use, is usually in the form that you have a label equals to the features plus maybe error. So the features, they usually come in form of linear combinations. We'll go to talk more about that. So we will be talking about weights, associated. So, but the point I want to make here is that on the left hand side of the equation, you have the label, and on the right hand side of the equation, you have the features. Is somebody raising up hand?
Yes, sir. Kind.
Yes, Candy. Any question, Candy? Candy, you have the floor. Your hand is up. Okay, maybe. Wow. So, is I hope everybody can see my screen. I hope nothing is amiss.
We can see your screen, sir.
Okay, great. So, uh, now get it right that for the model, most of the models will be considering. So on the left-hand side, that's where you have the label. And like I said, the label could be categorical or continuous. But for feature, it could be both. But for left-hand side, it has to be either of the two. And if it's either, then if it's categorical, if it's categorical, then you can only use the logistic regression. So logistic regression. If it's continuous, then you can use the linear regression. So that's the first thing I want everyone to be able to understand. So for our, no, for example, no, we will be talking about email, no, being classified as to whether it's spam or not. So this is categorical, which means again we can use logistic regression. We can also consider movie review, where the label is, either positive or negative. Again, this is an example or an application of logistic regression. So, but why logistic? Why do we call it logistic? So, logistic because it's a function, just like probability. So that function is able to map number to a value between 0 and 1. And that is of interest to us because we know probability lies between 0 and 1. So that function, when we use it and we put any number in that function, it will automatically constrain, so the value will lie between 0 and 1. And it is for this reason that we use it to predict probabilities. So logistic function is actually helpful when predicting probabilities. And so why are we interested in predicting probabilities? The moment we predict probabilities and the probability is close to 1, that can help us to determine whether that will help us to classify an object into whether a particular class or another class. So that is the main reason. So how does it work? And I'm going to show how it works here. For this discussion, Let us suppose, for instance, we have a goal, and the goal is the goal here is to classify a review. Uh, it could be a review of a particular uh, film or a particular video or any product, could be a product as well. So we want to classify whether the review is positive or negative. In this case, our label, of course, is binary. So label is binary. So which could be positive or negative, rather, or negative. So let's take one particular review. This is a particular review which says the movie is the movie was amazing and funny. That's a review. So the first thing we have to do is to turn the words in the movies into numbers. And that's what we try to do here. So if we look at words like amazing, then is it present in the statement? Because amazing, just a minute, please. So sorry. So, are you still there? Then to, are you still there?
Yes, sir.
Yes, sir.
I'm sorry for that. Well, I don't want to tell you the mixed, news, but sorry for that break. So I was saying that if, for example, we have this review, the movie was amazing and funny, then the first thing we have to do is to turn the words into numbers. And turning the words into number, we create a table like this, such that you have, uh, and of course, words like the movie was really don't express, including hand, will not express any specific sentiment, except those in the linguistic, if they can correct me. But words like amazing, funny, indeed, um, point to uh, a sort of sentiment. So if we look at the words and some other words, amazing, for instance, is present in that statement, fine. Uh, Funny is also present, but words like boring, which expresses a negative sentiment, uh, is not present. Terrible, you know, which also expresses funny, rather negative sentiment, is also not present. So when a table is formed like this, the next thing is to uh, generate a weight. So, and the weight associated with the words will then help us to uh, train the model, and then we will be able to use the weight also uh, uh, to compute the probability, as you will see later. So we need to get a weight based on um, the model training. Remember, we talk about splitting our data into training set and test set. Let's suppose we have trained and we now have a weight of plus 2.5 for amazing. That means we have to give that to positive sentiment. A weight of plus 1.8 attached to funny, that means that is a positive sentiment. But if the weight, we have a weight of minus 2.0 for boring, that translate to negative, and a weight of minus 3.0 for terrible, that's negative. So the weight is generated based on past training, based on the model training. So the third step after assigning weight is to now use the weight to produce probability. How do we do that? First, we have to get the sum of the weights and then apply the logistic function. You know, there is a formula for the logistic function. And then based on the logistic, once you apply the weight to the logistic function, you will get a probability value that lies between 0 and 1. So for instance, if the sum of the weight is 4.3, and you now apply the logistic function, and the value you applied is 0.9686 rather 0.986. Then because that value is close to 1, we can now predict that the review expresses positive sentiment. So that's how it is done. So let's, for instance, again, look at this simple example. So in this case, we have words like amazing, which is present. So we give it 1. And then the weight is 2.0, and the direction is positive in terms of the sentiment. For boring, which is not there, okay, so present is 0. Let's say the weight is minus 1.5. So because it's minus 1.5 is negative in terms of direction. The word funny, again, is present. And let's say the weight is 1.0. And then this is positive. So positive sentiment. So let's now compute the probabilities. So how do we, so the starting point for doing the mathematics, 1, we get the sum of the weights. And this expression, is what we use to get the sum of the weights. So since we are talking of a sentence, so we need a weight for that entire sentence, because you have amazing there, you have funny there. So the expression you see here will then be used to get the weight for the sentence or for the review in this case. So each word is a feature. So in this case, Z equals to, in this case, you have X1. Let me write here. So you have Z equals to B0 plus B1 X1 plus B2 X2 plus B3 X3. We can continue like that. Plus let's say dot dot plus bn xn. So this z is the sum that we are talking about. That's this, the weighted sum. The z is the weighted sum. The x's stand for each word in the review. So the x's stand, so those words are now regarded as the features. So x1 become the feature, x2 is also a feature, x3 is a feature. So each word in the review stands for feature. So after we have done necessary substitutions, so which means we are going to substitute value for this, substitute value for this. So this B naught in the document I actually use W instead of B, but that shouldn't bother you. But these constants are the weights. Those constants are the weights. Then the x's are the 0, 1. So if a word is present, if for instance x1 word, if it's present, then x1 will be 1. If it's not present, then x1 will be 0. Again, if x2 is present, then x2 will be 1. If x2 is not present, then it will be 0, and so on like that. So which means first you need to get the weights, and once you get the weights from your table of label and present, you are able to determine the sum, the weighted sum, by just making substitution. So for it to be clearer, so how do we get the weighted sum for this review? Remember the statement, which is the movie was amazing and funny. So we need to get a weighted sum. So first, we have to get the weight. This is a constant weight. Then we get this W1. We will get W2. So we get all those weights. For purpose of this discussion, let's assume that B naught, that's the constant weight, is this. And then the weight for amazing. The weight for amazing is 2.0. So which means for this B naught, we are going to substitute minus 0.5. The first word is amazing, so we need its weight, and the weight is 2.0. So we put that weight there. And then the Amazing, is it present or absent in that sentence? Is present. So X1 is going to be 1. So again, this substitution to this place based on this expression. The word boring is not in the word, but it has a weight of minus 1.5. So this is the weight, and this is an indicator saying boring is not present. Then the word funny has a weight of 1.0 and is present in the review. So we substitute here, and then we now do the arithmetic, and then we get this value as the weighted sum. So Z, which expresses the, which gives us the weighted sum, is 2.5. So that's the first thing we have to do, getting the weighted sum. So that's what this expression helps us to achieve. The second thing now is to apply the logistic function. Which gives the probability of positive. So it will convert the weighted sum to a probability value. In this case, that probability is the probability of the review being positive. So this expression, 1 all over 1 plus exponential raised to minus weighted sum, that is Z that you obtain here, will then give the probability that the review is positive. This expression is what we call the logistic function. This is what we call the logistic function. So let's apply it to our data. We've computed the weighted sum to be 2.5. So to compute the probability that the review is positive in its entirety, we now substitute in the logistic function. So we have 1 all over 1 plus e raised to power minus 2.5. That 2.5 is coming from, remember we call it the weighted sum. So the probability is approximately 0.924. And as to, so that is the second step, calculating the probability. So we have done that. The final step is to take a decision, which we call the decision rule. So the decision rule is if the probability that you have computed in step 2 is equal to or greater than 0.5, then that review is positive. Otherwise implies that that value is less than 0.0 is less than 0.5. So if it's less, then it means that review is negative. So you will agree with me that in this case, the review is positive, simply because the expression, I mean the value we have got here is far above 0.5. So this is just the simplest illustration or explanation of how we apply logistic regression. Is there any question up to this point? SAG? SAG,
Yes, sir.
are you able to follow?
I'm following.
Yeah. Just like that. Mercy, how about you? Mercy, are you there?
I'm here, sir.
Was it that you also struggle to follow?
Yeah, I'm following. I'm following. Yeah.
Yeah. Yeah.
Yes, sir. I'm following you too.
Vivian, how about you?
I'm following, sir.
Is it interesting?
The mathematics is a bit much, but I
No,
know that that's what they're shying away from. The mathematics is a bit much, and maybe somehow I've lost you somewhere, but with God, we'll follow.
uh, God will come later, but you do your own part. You didn't ask any question while I was going through. Uh, Nobody raised any concern. Ibukun, Emiola, I'm
Yes,
not
sir.
sure. Have you been following?
I'm trying to catch up, sir. This is my first time.
This name is not too familiar. Okay, Kehinde Oluyemisi, how about you?
Following, sir.
Following, or you are no following bumper to bumper?
I'm following, not that bumper to bumper, but I'm in the.
Not bumper to bumper, at least you are a few
Uh,
kilometers away, not even meters. Okay. What you should do actually is, okay, maybe what I will do now is to allow Kafaya to take you through again. Kafaya, are you able?
Yes, sir.
Okay. So you can project. Let's see. Maybe if they listen to you, they will be able to get it. I actually have another version, but so go through with them again. Then
Okay, sir.
after that, Honey can review, the question and multiple choice questions. So
Okay, sir.
let me just stop presenting now. Okay, you started. Okay, that's good. So you have the floor.
Okay, thank you very much, sir. Sir, should we run the arrow part, or we should just stop at?
Well, if you are able to go through, do you have the code?
Not yet, sir.
I can send it to you. So it makes it easy for you to just run
Okay, sir.
without having to type.
Okay, sir. Thank you, sir.
But the code is I use it for another data. It simulated its own data. So, uh, uh, but it's also what you have, exactly what you have in the document.
Okay, sir. Okay, sir. So, good afternoon, everyone. Are you see my screen now?
Yes.
Okay, thank you. So, our prof has already explained everything here, but I'll just summarize again for you to catch up with whatever you missed. Yeah, so logistic regression, as prof explained earlier, it has to predict categorical outcomes that are mostly binary. When we talk about binary, it means it has just two options, zeros and one, like yes or no, true or false, positive or negative, present or absent. The goal is to classify, the goal in this case study we have here is to classify a review, or let me call it a sentence. It's the same thing, right? Let me say a test or a sentence as either positive or negative. Now, what is the sentence we are talking about? The movie was amazing and funny. How do we go about it? This is what logistic regression will do for us. We want to classify this test. We want to classify this sentence as either positive or negative. The first step here is turn the word into numbers. Like I mentioned earlier, logistic regression only predicts binary outcome or categorical outcomes, right? Zeros and one. You are turning it into a number. It's either 0 or 1. And in what? It's either positive or negative, right? Now, in this sentence, we talk about amazing in this sentence. Is amazing positive or a negative word? You can tell it is positive, right? I think someone is trying to say something. Okay. You can tell it is positive. Funny is also positive. Now, how boring or terrible are this sentence? Because boring is 0 and terrible 0. Now, in the second step, you go by applying the weight. The model gives each word a weight. By predicting, we want to model. So in our model, you apply a weight is being assigned to each word. So when we talk about this, in this sentence, assuming we are given that the weight for amazing is 2.5, the weight and the values are not, they are not guessed, they are given. The weight for
I raised my hand, please.
okay, please go ahead.
For this step one, right, where the words are turned to number, are we the one turning it to number, or the model are turning it? Is the one turning it into number? God, I beg. Then
You are the
also,
one. You are the, okay.
do we give like, say we're the one turning it into numbers, right? So we give positive words 1, and then we give negative words like cos 0. Is that it?
Yes, positive is 1, negative is 0. When you say you give positive word 0, don't you think they are not correlated? And it's kind of confusing, right? It's like saying let yes be 1 and no is 0. You can go the other way around, but it's not ideal. It can be confusing. I don't know if you get that. Is that Vivian?
Yes, I do.
So
Thank
it's
you. No,
better to
it's not.
say positive
Let's see.
heritage or candy.
Heritage.
Okay, heritage. So do you get that?
Yes, I do.
Yes. So it's better to say positive is 1 and negative is 0. All right, so in stage 2, we say that the model gives each word a weight. Now, the weight for amazing given here is 2.5, funny 1.8, boring 2.0, and terrible is 3 minus boring minus 2.0 rather. Terrible is also minus 3.0. Those are negative votes. Those are the weight based on past training. Past training, you don't know is right. It is based on the data you have been given. But let's assume these are given to you. Now, the next step for you is to now add them and convert them into probability. How do you do this? This is where the logistic function comes in. But before them, you need to look at the sum of the weight. But what do we do with logistic? Let's talk about logistic function, because we need it to achieve the goal of classifying a test as either positive or negative. So what does this function do for us? Like Prof explained earlier, it's also known as the sigmoid function, right? It helps you to squash your prediction, or let me say your model, your output, into a probability value between 1 and 0. That's what the function does for you. Now, the first thing, let me move to where the function is. I'm coming back to that. So this is the logistic function here. This is the logistic function here. But before that, you need to get, you can see there's this P of positive here is the probability you are looking for, the probability that will tell you if a word is positive or negative. But what is this Z here? That's the sum of the weight. The weight that we are given, the weight that is assigned to each of those words. Now let me go back to this. Yeah. So that's what we have here. The sum of the weights passed through a logistic function between probability. I believe you understand that part. So let's just. All right, so to obtain the weight in this, to get the probability of the logistic function, please let me summarize again. I don't know if you are getting it, but if you want to ask a question, there is no need to raise your hand. Just go ahead, unmute, and ask. To achieve this process of classifying a test as either positive or negative, we need to follow a few steps. Logistic regression will achieve the goal for us by using the logistic function, right? There is the logistic function that will help us to scratch or turn our output into a probabilities, of course, between 0 and 1. But for you to use this logistic function, you need to get the sum of the weight or weighted sum. Now, the sentence we are looking at here is the movie was amazing. We want to turn this into numbers, and that's where we have this table here. Amazing is turned into 1. Amazing is a positive word, right? Funny is a positive word also. Now, a weight is assigned to each of these words, and which is what we have here. Amazing, funny, boring, terrible. Now, let's move on to. Now, each word in this, to get the weighted sum, remember the equation is this. This is the equation for Z. Z stands for the sum of the weight. That's the, or let me say the input to the logistic function. What do you input for you to get your probability? That's the Z. So we call it input or the weighted sum. Now, each of these X values here, they are the features or each words in a particular sentence. And these X values, they are binary. They are either zeros or 1. Please note that. They are either 0 or 1. Now, for amazing, let me go back here. Each word is a feature. I already mentioned that. The model learns how much each word votes for positive or negative. That is how much each of these words contribute to making the review a positive or a negative review or sentence or sentiment, as the case might be. So the votes are added up to become a probability. So each of these words, we have amazing, boring, and then funny. For the present here, is the word positive or negative? For amazing, that's where we have 1. The word is positive. Is the word positive or negative? For boring, you can tell it is 0 because the word is boring, and funny is 1. These are the weights that are given. Now the both direction in this case, they are positive, and that's why we have 1 here. Negative, positive. Do you understand it to that point before we move forward?
Yes.
Okay, can only hear one person speaking. I need to hear 2
Yes.
more voices. Move forward. Okay.
I understand it, ma.
What do you say?
I said I do understand it.
Okay, thank you very much. So let's now go to the step of classifying our test. Now that we have converted them to numbers, the next thing for us is to get the sum, the weighted sum or the sum of the weight. Why do we have to take this step here to get the sum of the weight? Because we need this we need it as an input to our logistic function, which is this. Now, how do we obtain this? Let's use the example below here. The example given is that the intercept, not here, is the intercept, is given as minus 0.5. Then the first weight here, which is if the word is amazing, we are given that the weight is 2.0. And amazing, of course, the
Please, I would
vote
ask, where did we get B from? The B
mean
not.
the B naught is part of the equation. This is the equation to obtain the weighted sum. The B naught is called the intercept. Do you get that? It's part of the equation. And the values for all this are given here. This is what we want to use to classify the text. Is that clear?
Sort of. So we don't get the B naught value from the one above. Is it like a fixed value?
It is given to you. You don't get it from above. Do you get that? The B naught is the intercept and it will be given to you. Is that clear? You don't
Okay,
get
yes.
it by turning the words into values. Is that what you mean?
Yeah, that's what I was asking. So you already said it to be
Okay, so
provided, like the B naught to be provided.
yes, that's it. And in this case, our intercept is negative. It can also be positive, which is 0.5. Now, each of these weights are also given, as you can see. The first weight here for amazing, the word amazing, is 2.0. The second weight for the word boring is minus 1.5, and then funny is 1.0. Now for the X is, I think someone is raising up his hand. Please go
Yes,
ahead.
it's royal. The first table where we were to choose positive and negative, there were 4 words: funny, terrible, yes, and boring. But here I'm seeing just 3 words.
Yeah, we are using 3 words in this particular example.
Okay.
Yeah, we can decide to add variable to it. But we are using 3 variables. What are our variables? Those are our features. What are the features? Those are the words we are using. That's amazing, boring, and funny. For the sake of this example. Exactly.
Yes. Thank you.
All right. So, and for the let me call it, for the sentiment or the review, we already classify each of these words as either positive or negative. Positive is 1 and negative is 0. That's why we have here for amazing, the value is 1. Remember, these are features and they are either zeros or 1. Then for boring, it is 0. For funny, it is 1. So now substituting these values into our equation. Remember, the goal is to get the weighted sum. 0.5, which is our p naught, we are substituting into this equation, the equation here. Then that's where we get this. You might be wondering, where is the n in this case? I assume you know that n is depending on the number of variables we are having. In this case, we are dealing with 3 words or 3 variables. So this is our equation. W1, x1 plus W2, x2 plus W3, x3. But this equation here is generalizing the weighted sum. You might have more than 3 variables. You might have 4, you might have 5, you might have 6 to deal with. Then you have plus W4, X4, and so on. Now, our W1 in this case is the amazing, the word amazing, and the weight is 2.0. In some case, like Prof used earlier, it might not always be W, it can be B. Do you get that? So W2, the second word here, the weight is minus 1.5, which is this. Then the W3, which is 1. These are the votes for amazing, for boring, and then for funny. If you press this on your calculation, then your calculator, you get 2.5. Now, this is our weighted sum. That's the Z. Where are we going? Is to convert the model into a probability. That's where the logistic function comes in, which is this. That's the next step. Now, since we already have our Z, let's put our Z here as exponential minus 2.5. Then we have this. This is a probability value. The goal for us is to classify the text as either positive or negative. Now, this takes us to the third step here, the decision rule. How do we decide if that sentence is positive or negative? That's where this comes in. If the probability is greater than 0.5, then the text or the review or the sentence is positive. That's a positive sentiment. Then otherwise, it is negative. In this case, our probability is greater than 0.1, and that makes it positive. Do you understand to that point? I need someone to talk.
Yes, I do.
Okay. Any question before we move forward?
Yes, I have a question. So
Okay.
this thing now that we just did manually here, right? Is there like a code that we can just put it on R and then we get our answer straight up instead of
Yes,
this manual? Okay, thank you.
yes, there is. And that's what we are going to be looking at in R software. Because it's in mostly real life situation where you have to classify text. a very long collection of tests. You can't do it manually, right? That's the use of software. That's where the software comes in. Now, look at these key takeaways. Logistic regression is simple, interpretable, and effective, right? Which shows which words drive the prediction. Do you agree with that? Then the logistic function turns any score into a probability. That's what the logistic function does for this score, this weighted sum. Now, let's look at the R codes here to practicalize what we have done. Okay. I think Prof said it's going to send the codes.
Yeah, let me send it now. Sorry.
Okay. Okay, sir. Okay, so I'll share my R screen now. Please confirm you can see my R now.
We can see it.
Okay, so let's quickly practicalize it. We don't have much time again. Now, we already have a collection of tests, but before we go there, for you to carry out some tests or to use some functions in R, you already know by now we need some packages. Not in all cases, but we might need some packages. That's why we have this install packages. And then when you install, you call the packages you need. And that's why we have this. Now we have collection of tests. This is what we have here. Test. We have this. I love this movie. The film was terrible. Amazing story and acting. The likes. So each of these texts have been labeled. The label we want to classify, what this is telling us is we want to classify each of these sentences as either positive or negative. And that's where we have labels. They are labels. Then 1 is for positive, 0 is for negative. Now, the first thing we need to do is convert this to a data frame. This thing is still stored. Okay. Let's give it a minute. Trying to install the packages I need. So, but why we do that? The data DF is for data frame here. is to convert the text and the label as a data fix and data frame that is in a table form. Then we form a corpus. Okay, I think the installation is. Let the installation be done so that it can get along more. Just.
Dear customer, the MTN number you will.
I can't hear any voice. What's that?
Yes, we are waiting for the installation to be done, and then we proceed.
Oh, okay. Oh, you've not done the installation.
Yes, sir.
Okay. Or you want me to do it from here so to save time?
Yes, that's fine, sir. Thank you, sir.
Okay. So that's fine. Yeah. Are you still?
I'll stop sharing my screen, sir.
Okay, so let me share from here. So this is the script file. So you need to install the package TM, that's text mining, and cat tools. But you don't really need this one for this discussion. But for subsequent one, you will need. So this line tries to load the package. So once you run it, it will tell you it's loaded. Then this one now loads the cat tools, and then so this is the review. I love this movie. Oh, is this the one I want to do? I don't. This is sorry. I think I mixed up. Is this the one I sent to you?
Yes, sir. That's it, sir.
This is it.
Yes, sir.
Okay, fine. So, so this is.
No, sir, that's not it, though.
This
one is the one you sent to us is the one with just 25 rows of code.
25
rows of code. Okay.
Yes, this is it.
Yeah.
So here we now store all the reviews. This is the first review in quote. I love this movie. This is the second review. This film was terrible. This is the third review. Amazing story and acting, and so on like that. We also have another review. This is worst movie ever. You know how people, are so blunt in the way they speak and do their review. I'm happy with the plot. I am sad about the ending. So these are the reviews. You need to see how we put the reviews uh, together in this function called the collector function. So which collects all the reviews and then uh, save them in this uh, text, uh, what do you call it now? If you like it, vector, and then these are the labels. So this review, for instance, this is the first one. It's labeled as 1, where 1 is positive. This other one, this film was terrible, is labeled as 0, where 0 is negative, and so on like that, and so forth. So we now put this in form of table so that we put them in data frame. So if I run this text and I run line 6 labels, then the data frame, which I could name DF, everything will now be stored there like a spreadsheet. And then you can see the data if you so wish. Line 8 will now show the data. So this is the data. So you have the text and you now have the label. So the first one is I love you. I love this movie. And then the label is 1. The second one is this film was terrible. So we label the sentiment as negative, and so on and so forth. So we could have hundreds and thousands of reviews like that, and then we label them accordingly. So we create a data frame like this, to make the analysis easy. Then we use the corpus function to create the vector, to create the vector text. So we run equation 9, and then we need to, some of the words you have capital letters, so we need to convert the capital letters to lower cases. So this line 10 will do that for us, convert all of them to lower cases. This one will remove punctuations. If you know that we have exclamatory, yes, we have full stop and so on. All of that are not necessary in our analysis. So again, we remove all the punctuations, and then this one removes stop words, stop words like if you have and, what other ones? I am and all of that. So those ones are removed. So you have that. So you have the document term matrix. Use this to now convert the corpus, the remaining corpus now to what we call the document term matrix. Uh, in other words, it's now going to create a matrix for which all of them uh, will be assigned. Yeah. So this is the summary of the matrix, so to say. Uh, we will learn more about all of this later, but these are sort of uh, key indicators about sparsity. Uh, you know, if words, if you have words that are rarely occurring, or frequently occurring, and so on like that. So the maximum term length is 8. You see that when I uh, show run line 16 now to be able to see the data. So this is the term matrix, the word love. Some other words have been removed completely, like hand, the, and so on. So punctuations have been removed. So these are the remaining words. So in line 1, for instance, this tells you that wherever you see 1, then in the first review, love is there. In the first review, movie is there. In the first review, film is not there. So all the remaining words are now in columns. That's what we call document term matrix. So in that, on the row, you have the review serial number 1. So it could also be document 1, document 2, document 3, and so on. So you have, for instance, in document in second review, there is no word love there. So if you look at the second review, the word love is not there. So the word movie is not there, but the word film is there, the word terrible is there, and no other word is there. In document 3 or review 3, the word love is not there, the word movie is not there, the word film is not there, the word terrible is not there, but acting is there. So that's how you interpret all of this. So this is what we call document term matrix. So we are ready for analysis, because this is the data you actually want to analyze. So now that you have the data with set seed, because we want to split the data into training set and test set. So if line 18 will help us to split the data. We will also attach sentiments that we have indicated here. That is the label. We will add that sentiment to it, and then split in the ratio of 70 to 30. 70% for training and 30% for testing. Once you put 0.7 in the split ratio, it automatically takes the 0.3 to be the training set. So we run line 17, and then we split. We can now use that to get the subset. So I'm going to call for the train set after splitting, and also call for the test data after splitting. So let's see the training data. So this is the training data, which means after splitting, review 1, review 2, review 5, review 6 are selected to be in the training set. Then again, after splitting, only review 3 and 4 are left as test data. So once that is achieved, then we run the model. So sentiment will be the label which I told you. So the sentiment is either 0 or 1. So, and then by indicating using the tilde here, we are saying sentiment as a function. So of the remaining features, all these features which include love, movie, film, terrible, acting, all of them will now become the features. So, and then this one is indicating we are using the training data, and binomial means we are using the logistic function. So we run that, and then we get the summary. Good enough, this summary will now help us to get the weight associated. You remember when we were doing that? So this is the weight that is constant for all of them. This is the weight for love, and is positive. Movie not available. Film, this is the weight. Then happy, this is the weight. Only those three words have weight in this. So with this weight, we can now compute probability as we did in the illustration using the logistic function. So, but let's predict the probability. That's what 23 is going to do now. So it's going to predict the probability using the weighted sum. So it's going to use the weighted sum to predict the probability. So line 23 runs that, and then you now need to you know what happens when we predict the probability. Of course, if I call for the predict probability now, you will see the data. So this is the predicted probability. No, for the first predicted probability for no is 0.66. Predicted probability for yes is this. Remember, we are interested in yes. So on the basis of that, line 24 is now going to classify whether this review is positive or not. So, and it's going to do that it's going to classify as positive, that is 1, if the probability is greater than 0.5. So if I run this now, it has done that, and we can say, okay, print the predicted probabilities. So it's going to print the predicted probabilities. So of course, it's predicting the predicted probability for the test data, which was not used to train the data. So the predicted probability is 0 when actual is 1, which means the model predicted that review 3 is negative. You know, that the sentiment expressed uh, by reviewer 3 is negative, when actually the sentiment, you know, was positive. But for 4, it predicted correctly. It predicted 0 for 4, when actually is negative. So the prediction for 4 is okay. So we have, you know, 50% accuracy in this case, because 1 was correctly predicted. That is, reviewer 4 was correctly predicted, and 3 was wrongly predicted. So this is the, I don't know if there are questions, or if Oni will quickly go through. We still have about 7 minutes. What do you want us to do? Vivian, what do you want us to do? Do you want her to run through the multiple choice questions to see whether you people can?
No, sincerely. We wanted her come so we can discuss about extra classes and this thing. So it's okay. I mean, how do you say it? Let Honey and Kafayat come so we can discuss. Because honestly, I don't even really understand this interface of R. So maybe a physical something would help us out.
Yeah, you see, you need to do a lot of extra stuff. But let me leave you with Oni, and so
Thank
that
you, sir.
you can discuss freely, like lady to lady and stuff. So yeah, so
Okay, sir.
thank you.
Good evening, everyone.
Good evening.
Good
So
evening.
yes, Vivian, I understand that you did not want to do the multiple choice questions. We
I did
already
not
have
say I
them
did not
in
want to
pool.
do. No. I, honey, I did not say I did not want to do. I said that right now our head is hot because it's been. I hope you understand that we are all art students here. So all these programming things and
Okay,
mathematics things is a lot. Yeah.
I understand. I understand. The multiple choice question is they are really focused on the theory part of it, not the R part. Do you understand? Not the programming part. So if you will still want to do it, I already have it in a poll, so you just have to click your answer. That's if you would, if the class will still agree to do it. If not, we can shift it to another day. What would you want to do?
The class, please, you people should talk.
Ezeji, Kehinde, Mercy, Bukon. Please let's talk. Where is Heritage?
If the multiple choice questions are few, like if there are just 5 questions, let's quickly do them.
Okay, I would just send the poll. You just have to click your right answer. But there are 10 questions. You know how the questions are. There are 10 questions. So just answer the ones that you can, maybe in the next 3 or 4 minutes, if it's possible. Okay, so let's quickly do that. Okay, so we can check the activity icon. I'm already sending them. Can we see the questions already? If you're having difficulty in locating where it is, just let me know so that I can guide you. Okay, so I can see that 2 people are the ones attending to the votes.
Let's just stop. It's like they are overwhelmed.
Okay.
Yeah, so maybe you start from their next class.
Okay, okay, sir.
Or you people can discuss on possible tutorials, whether virtual or physical.
Okay, okay, sir. All right. So as regards the tutorial, we'll be expecting to hear from you, from the class. Let us know the dates and the time that will be convenient so that we can check with our schedule as well to see if it will work for us. Is that okay, class? Vivian, Mercy?
Yeah, our class rep will reach out to you.
Oh,
Kafayat.
okay, okay, that's fine. All right, so do we have any questions for today?
No questions, ma.
All right. So if there are no questions, we would like to call it a day.
Yeah. Thank you very much.
You're welcome.
Who is breathing like that? Who is breathing like that? You better don't crash on the. Okay, so take care of
All right.
yourself.
See you
Bye.
next week. Bye.
Bye bye.